Hi guys, my name is Carlos, and in this lab I'm going to create this virtual network on Azure. I will be using Terraform to create 4 subnets: the web tier subnet, the app tier subnet, the DB tier subnet, and the Bastion host subnet. All of these subnets will have 4 NSG, so let's get to it. First for all, you need to add the Azure uh, Terraform provider. You are going to go to the website Terraform, and here in the providers select copy the Terraform provider, the required provider, and paste into the version.tf. Uh, Here in Visual Studio Code you need to install the required extension in order to work with Terraform, and you need to uh, login into your Azure account and select the subscription uh, in which you are going to deploy the resource. The next file that I'm going to create is the generic input variables. The input variable serves as parameters for the Terraform module, allowing aspects of the module to be customized without altering the module's own source code, and allowing modules to be shared between different configurations. We're going to see in a couple of minutes how am I going to use these input variables. The next file that I'm going to create is the locals.tf. This file is a local value, describe the local values that I'm going to use. A local value assigns a name to an expression, so you can use that name multiple times within a model without repeating it. Local values are like a function's temporary local variables. Once a local value is declared, you can reference in your expression. Local values can be helpful to avoid repeating the same values or expression multiple times in a configuration. If overused, they can also make a configuration hard to read by future maintainers by hiding the actual values used. The ability to easily change the value in a central place is the key advantage of local values. In short, you need to use local values only in moderation. Like I said before, you're going to see how this file, the generic input variables and the local the locals.tf are used in the code. The next files that I'm going to create is the random resource and the resource group. The random resource use the random provider in Terraform. So let's search for that and then go there and understand on a high level about it. So the random providers allow the use of randomness within Terraform configuration. So why do you need randomness in your Azure configuration? Let's talk about your Azure Cloud perspective. From Azure Cloud perspective, if you take any storage account resource, for the storage account resource, the name should be unique across the cloud. So whatever the name you define for your storage account, it should be unique across the entire globe. So how you are going to generate that name? Sometimes whatever you have created might already exist. So for that purpose, you can create a random string resource and then associate it with the initial prefix. So here in the random provider, I just go to the random string and copy this block. In my code, I'm going to use the length of 6, and don't going to use the upper and special character. The next file that I'm going to create is the resource group. Here you can see how I'm using the the variables that I specify in the local files. And here you can see that I'm going to create the name with a specific part that is random. Then I'm going to create the VNet input variables to help me to configure the virtual network. Here I'm going to create the VNet name and the VNet address space variable. The type of this variable is a list of string, and here is the default value that I'm going to configure for this VNet address space. I do the same for the next resource, the web subnet name. I create the web subnet name variable and the web subnet address space variable. Here you can see the values that I specify as default. Then I create the virtual network file in which I'm going to use the same location as the result group. You can see here the resource group that this instance is used here to specify the location of the same resource group. And I'm going to use the tags that I create in the local, in the file, the local, the common tags. The next file that I'm going to create is a web subnet and the NSG file. Here I'm going to specify the arguments for each resource. For the web subnet resource, first I define in this block the type of resource from the Azure provider and call it the web subnet instance. This is the name of the instance of the resource. Here in the name you can see the name of the resource group. This is the type of resource provider. This is the name of the instance of the resource group, and this is the name of the argument of this resource group. You can see here in the resource NSG that I create the name that is composed of the web subnet name siphon NSG, and I use this here the same location that I'm going to use in the resource group. I need to create the resource to associate the NSG and the subnet. Here I'm going to provide the ID of each resource that I'm going to associate. Another thing that I'm going to do is to create this tuple of variables. Each variable is composed for the key and the value, and I'm going to map these values within the for each. What I'm going to do is to create each rule for this NSG to implement in this for each three different rules. Here I'm going to use each key and each value in this statement. Thanks to the for each I will do the same for the app subnet and NSG file. We'll create all the arguments, the resource, the NSG rules for each of these resources, and then I'm going to create the VNet output files. The output values are like the return values of a Terraform module, and have several uses. A root module can use output to print certain values in the CLI output after running Terraform apply. So this output variables uh, have the argument of description and value. The last thing that I'm going to do is to create the Terraform TF bars files. So Terraform TF bars is nothing but whatever you have defined in your generic input variables. So those values here uh, explicit default can be overridden using the Terraform TF bars files. Here you can put all the values that you are going to implement in the real implementation. So in order to implement all this, first we need to log in into your Azure account. Then you need to select the subscription that you're going to use for the implementation. And then you need to move to the required file. In this case is Terraform manifest. Okay. This file. Then you're going to use the Terraform Unit command. This command used to initialize a working directory containing the Terraform config files. This is the first command that should be run after writing a new Terraform configuration. After that, I'm going to use the next command is Terraform validate. The Terraform validate it is going to validate the Terraform configuration files in their respective directory to ensure that are significantly valid and internally consistent. Like here, it says that it's success. The configuration is valid. Then we are going to plan the implementation. Let's see what is going to happen. So after that, here we can see okay, Terraform plan. And this command is going to create an execution plan in which Terraform performs a refresh and determines what actions are necessary to achieve the desired state specified in the configuration files. We are going to see here all the resources that are going to be created. Okay. You can see that the variables that we specify in the terraform.tf bars are going to override the variables that are in the generic input variable files. This is all the resources that I'm going to be created in my subscription. Is 27 total resource. Here you can see the change to outputs. Next, we are going to finally apply the configuration. And finally, the last command is Terraform I auto approve. This is going to finally implement all those resources in my Azure subscription. This is going to take a few minutes, so let's get back when it's done. As you can see, all the 27 resources were configured and applied in the subscription. Here in my subscription, you can see the resource group that has been created with the 4 NSG and the rule for each NSG that were created with the help of the for each sentence to port the key and the value of the variables. You can see too the you can see the VNet and the 4 subnets that were created. So the last thing that we're going to do is to delete all the files. For that, we are going to implement the Terraform apply destroy autoproof. This is going to delete all the resources that we have just created, and it's doing that by comparing the Terraform TF states, the desired state configuration, with the desired configuration. So this is all. Bye bye. Thank you for watching. To the next video.